We're parents, teachers, and educators, and like you, we're passionate about restoring our culture for Christ. This is Veritas Vox, the voice of classical Christian education.
Hello again, and welcome to another episode of Veritas Vox, the voice of classical Christian education. Today we have with us Paul Foerster, a math instructor for his career and an author of math textbooks. Paul, welcome.
Thank you.
For a long time, maybe as much as 2 decades, we have been using Paul Foerster's work for Algebra 2 and pre-calculus. And in recent years, I've gotten to know Paul, and it's been a really exciting road as we have talked to him and started working with some of his copyrights to bring them into the Veritas fold. But before we jump in there, Paul, maybe you can tell us a little bit about yourself.
Okay. Well, I was born in England of American parents. My dad worked for Cincinnati Milling Machine Company and was sent to England to open their British branch in the 1930s. And I was born there 90 years from tomorrow.
Yeah, I heard that tomorrow is your birthday. Now, tomorrow will be yesterday or prior to yesterday when people hear this, but as we record it.
Okay, anyway, we lived there before and after World War II. During World War II, my mother, sister, and I came back to the United States, lived in Cincinnati, while my dad stayed there with the Milling Machine Company and eventually with the Lend-Lease program, where we would lend them destroyers and they would lease us air bases. We came back from England when I was 15 years old, in 1950, moved to Texas, which is my mother's home state, and to Sutherland Springs, which is a little town that had 300 people.
Wow.
In 1950. It received national recognition or note when the man went in and shot people in the Baptist church. But anyway, the child of one of my former colleagues at Floresville High School was the one that eventually put that to an end. Anyway, I went to school in Floresville, where I should have been a sophomore. They said, "Well, what did you do in your English school?" I said, "Well, I had 4 years of algebra, I had 4 years of geometry, 2 years of trig, 2 years of chemistry, a year of physics, and so forth." They said, "Well, we're embarrassed to say that we have nothing to offer that you haven't already had."
Oh, my word.
For Texas history, which they didn't teach in my English school, and Spanish. So they said, "We'll put you in the senior class. We'll let you take the geometry," which was their top course at the time, geometry over again, and you can take English and Spanish, and if you can do the work, we'll let you graduate. Well, it was easy in the geometry class. If the teacher didn't know what to do, I would tell him. Anyway, I did graduate the week before my 16th birthday, and spent a year at Trinity University majoring in chemistry, then moved to the University of Texas to major in chemical engineering because I thought that that would be a better option. As the Korean War was going on at that time, I figured it would be better to be in the military as an officer than to be recruited to be a foot soldier or something. So I enrolled in Navy ROTC and got my commission and my chemical engineering degree in February of 1957. Fortunately, I got interviewed by Admiral Rickover for the nuclear propulsion program and was accepted, and spent 4 years in Washington, D.C., designing and constructing nuclear submarines.
Wow. Wow.
I had only 2 days of sea duty during that time, both of them in builders trials of nuclear submarines. I saw a
And
couple of
apparently you
submarines.
survived those tests.
Oh yeah, and I thought that was a very interesting experience. I did get to go to 6 months of reactor school in Oak Ridge, Tennessee,
Wow.
and that turned out to be a life-changing event also. It was there that I first understood what definite integrals really were. In my university experience, they were formulas which you used and you did this with under certain problems. And I had no conceptual idea. But the reactor analysis person who was the a person that taught the gutsy course there said, when you find out the power level being generated by a nuclear reactor, you imagine the reactor divided into small parts. You find the amount of power in each part and then add them up and take the limit. And that's called definite integrating. And I said, oh, so that's what it is. So that
There
just
is nothing
beyond,
more exciting to a guy that
uh,
loves math like you and like me than a real application of what we learned in a book.
yeah. So I came to realize that in order to make intelligent applications, you must understand the theory. There were no formulas for building nuclear reactors when I was there. It was all new. You had to go back to basic principles. So that was a milestone in my life and convinced me that it is important to learn the theory, not just the applications. Toward the end of my Navy career, um, I thought when I get out of here, I want to uh, get workshop tools because I had been to Fort Myer in the Washington area, built furniture and model ships and things like that. I thought I need to have a workshop when I get out of here. So to earn money to get workshop tools, I started tutoring high school students in the evenings. And what I found there was the thing that I really liked was the aha when they caught on.
Uh, Boy, that is a teacher's heart at work,
Uh,
isn't it?
and so I decided rather than staying with Admiral Rickover, who wanted me to stay as a civilian, I would uh, leave the nuclear power business and the reactors and engineering and become a teacher. I found that Texas A&M, the rival school of University of Texas, had the best program for getting engineers into the classroom. So I went there for a spring and a summer, took courses for the education courses that I needed for certification, and started my chemistry master's degree. But my wife of 5 years got pregnant at that time, and we were anticipating the birth of our first child. And I thought, well, I better go out and get some experience teaching to make some money so that I can afford the child. So I started interviewing, interviewed a number of places, and finally wound up at Alamo Heights, where the superintendent said, well, we don't have a chemistry job available right now. Why don't you come teach math for a year or two? And when the chemistry opens up, we'll let you move you into that. Well, here I am 50 years later, uh, still teaching math. I did get an academic year institute from the National Science Foundation to take off a year and get my master's degree in mathematics. So I have done that.
Yeah. But it's notable. I want to make sure the people that are listening didn't miss that. You taught at the same high school, Alamo Heights High School in San Antonio, from 1961 to 2011,
That's 50 years.
50 years in one spot. And in 1983, somewhere in the middle of that, you received a national award for the Texas for excellence, presidential award for excellence in mathematics, the Texas application of that. That's remarkable.
Under President Reagan, it was the program was conceived to show the public that there really are good teachers in the high schools.
Yeah.
So each state was allowed to select one science teacher and one math teacher to receive the award.
Yeah.
and I was the first one from Texas.
That's incredible. Well, I want to jump in here and ask you some questions
Sure.
of things that you've learned from this really incredible career in teaching math in the context of a very difficult point in America with regard to students learning math. What have you learned about secondary school math students? How would you describe what you experienced as you taught them?
You have to take your students seriously. You take yourself with a grain of salt, but you take your students seriously. And you do things that you think will prepare them for what they're going to face when they get out in the big wide world. Um, the uh, there are several things that have stood out in my mind. One of them is that in order to understand what the mathematics is all about, you've got to do it. You've got to um, do the actually do the mathematics. You can't just hear about it or read about it. You got to do it yourself. So I started writing what I call explorations, which is a non-boring name for worksheets. I wrote my first one when my son, who was my second child, was on the way, and I had to take paternity leave. I wrote my first one for my trigonometry class, and it was pretty much a disaster because I didn't really understand what I was doing. But eventually, I got to writing explorations for my students, which would be problems that involved uh, variables that really vary. Now, this means that a variable is not just some number you're looking for. It's not, X is not an unknown number. X is a number that varies. It's kind of like the memory location in a computer. It's a place where you store numbers one at a time. And since you can store various numbers in that place, it's a variable. It's always called X, but it has different numbers at different times. So I wrote problems in which the variable really varied. And I got so many problems like that that I had to write some materials to go along with them to lead students into them. And I got more and more things that I was retyping on purple dittos every year.
I
Um, and in
still
self-defense,
remember how good they smelled.
you don't want to inhale them. Uh, there was so much there that I finally put them on mimeograph stencils that could be run every year. And this is my second year algebra course. And
Yeah,
year
that's one that we use. What is key to learning? As you look at students, you have dealt with tens of thousands of them, almost certainly over the years. What is, maybe that's a bit of an exaggeration, but certainly a lot. What is key to students learning complex math? You start with Algebra 1 and go the whole way through calculus. In the books that you've written, clearly you understand the material, but tell us about the students too.
The students, you have to convince them that what they're learning is not necessarily difficult, but there are certain things that you have to know in order to fit things into what you are learning. Like the variables really vary is a concept that they need to know. But the main thing is to convince them that you are on their side. You are trying to do things for them that will make their lives better. Um, my first idea when I went into teaching was I want to teach the academically talented and teach them critical thinking skills. But
You enjoy the gifted more than the ones that are
that, that
harder
was
to bring
that was
along.
my idea.
It's
But
an interesting question, and I've observed it. I calculate that I've interviewed more than 1,000 teachers for what we do.
mhm,
And one of the questions I've realized is important for me to understand about a math teaching candidate is which side of that continuum they tend to favor and enjoy.
mhm. Well, we had a very insightful math department chairman who said each teacher in in the department is going to teach at least one lower level course for academically not talented students.
Okay.
So I had a year teaching what the Texas called Fundamentals of Mathematics, which was a course designed for freshmen who were at least 2 years behind in mathematics. And so I got this class of unruly kids. Um, and I started working on things with them to show them that there really were things that they could learn. I developed various techniques. I developed a flow chart idea. Uh, and I noticed that the students would respond better to things that were on separate sheets, and even better if they were handwritten and not typed.
Interesting.
And so anyway, I had the uh, when to control the unruly students, I did various things showing them that I was uh, on their side, like Eva, who was bigger than all the rest of the kids and louder than all the rest of the kids. I made her the class cheerleader. Um, and whenever there was something that they had to memorize, I would have her get up there and lead a cheer. Per means divided by, cent means 100. So per cent means divided by 100. Per means, and she would do over and over, and the class would repeat that. And I found at the end of the year, although it was an ordeal for me to do that, I found that I really had made a difference for these kids. Eva told me on the last day of class, she said, "Mr. Foerster, you were nice to us." And I thought, wow, that made my year.
Yeah, I'll bet it did.
Uh, I learned how to deal with those who thought they were not good at mathematics, um, and convince them that uh, actually the buzzwords that's going around the mathematics community now is growth mindset. Have you heard that
I'm
term?
not familiar with that term, no.
Mindset. If you want to look up, have your people look up something. Look for Carol Dweck, Dweck, professor at Stanford. She's one of the leaders in this. And the
Okay.
idea is you may not be good at mathematics, but you can get better. You can grow,
Absolutely.
in other words, and
Yeah.
that's growth
Yeah,
mindset.
I don't believe that everyone is equally talented, but I believe that everyone is capable of learning.
Capable of learning. That's exactly what it is. So that's what I found with my kiddos that um, were 2 years behind as freshmen in mathematics. I could do that, and I enjoyed that. Kid comes in. Oh, by the way, I was one of those people myself. In elementary school, I was second worst in arithmetic.
Is that right?
Only my best friend Eddie was worse than I was.
It sounds to me like you guys were having too much fun in the back of the class and it had nothing to do with
So
ability.
when a kid comes in and says, "Mr. Forrester, I don't understand this," I sit down and tell me about it. I've been there. I know where you're coming from.
Yeah.
And they would tell me um, what they were having difficulty with. And I would not tell them answers. I would ask them questions. Um, I had actually
Socratic
was a
reasoning
teacher.
works in math too.
Uh, one of my fellow teachers was terrified of having to teach slope fields, which is what kind of like what you see on the weather forecast,
Right.
where it shows you which direction the wind is blowing at every point. Um, and she said, "I don't know how to do a slope field." I said, "Sit down and take your pencil and put it somewhere on the paper." And she did. And I said, "Now draw a line." She said, "Where?" I said, "Anywhere." And she drew a line. I said, "Okay. It can't cross the slope lines. It has to go along the slope lines. So erase it and try again." And she would try again. And she said, and then I said, "Oh, you're aiming for the points. You're not following the path of the slope. You're looking for the points. It's not connect the dots." And she would erase it and start over again. And in about 10 minutes, she knew what a slope field was, and she was
Yeah.
afraid of it.
Um,
Anyway, that's
I have seen that in math curricula where the authors have been very good at understanding what a student will understand. And I'm sure that your 50 years of experience, I understand you wrote the books that you've written before you finished teaching, but nothing helps the teacher like experience with a variety of students.
That's right. It was good for me.
Yeah. How would you describe, is there anything we agree, we talked about this before we turned the recording on too, that students kind of come in uh, along a continuum where you have the slower students or the students that find math difficult. And then you have the curve, and in the middle of the bell curve, you've got most kids. And then on the other end of the curve, you have the kids that find math comes easy. Have you any theories that would help us understand how that happens? What causes a student to find math more challenging or come more easily?
I'm not quite sure how the brain works with regard to mathematical ability, but I do know that when you um, when you actually do things, when you have trouble with things, and then overcome your trouble, it makes structural changes in the brain.
Interesting.
There are actually synapses that develop because you had trouble. Sometimes a student who gets it very easily and breezes through has no change in their brain structure, whereas the one who had trouble and learned from the mistakes
Mhm.
does have a change in the brain structure. So um, I like to challenge my more able students and get them to make mistakes and then be able to correct their mistakes, just as well as I like to challenge those who are less able and rejoice in their finding out that they really can do some things.
Yeah,
So
that's really neat.
there's a lot of individual work where you have to kind of sound out your students and find out what they're doing. Like there was Derek in my calculus class who would sit there at his desk like that, staring at the board. And I said, Derek, aren't you going to take notes? No. And on the test, Derek was the one who got them right. He was the one who was able to do it because he was a very visual person.
Yeah,
So if he had taken time to take notes, it would have been to his detriment.
yeah.
So you've got
So
to
learning styles are applied to math as well.
absolutely,
Yeah,
yeah.
yeah.
Um,
Let me change the subject here because I think people will value what you have to say about this. America has shown itself to be, by international accomplishment, well down the list of countries. How does America recover from its current international ranking?
I wish I knew. Um, I know that we have to encourage talented people to go into teaching,
Okay.
and the atmosphere is not that way right now. In Texas, um, we have many teachers who are teaching who are uncertified because the certified teachers can get positions doing other things besides teaching
Right.
and are able to afford their families. I was fortunate to have a source of extra income uh, that allowed me to be able to teach without jeopardizing my three kids' education and so forth.
Yeah.
So, getting teachers in the classroom
So
who
quality of teachers is a key ingredient.
quality of
What
teachers is,
what
yes.
has caused the system to be on what I'll call an educational dumbing down? Where has that come from? My sense, one of the correctives that I would answer with would be to expect more of students at younger grades, and they will build on that. In math, one of the disciplines that builds on what's been learned previously, unlike some others, like say history or literature, um, what you did 5 years ago affected 4 years ago and keep going and affects today. Is that part of the problem? Where did the dumbing down come from?
Part of it is the way we test. Um,
Okay.
in my English school, we never did multiple choice tests. We never did true false tests. Um, and there was a national exam you took at age around 13 or so called the College of Preceptors exam, in which you actually worked the problems. You worked the geometry problems, and they were read by real live people who graded you on how you did it. So there was no um, test taking skills. There was just mathematical skills. You had to know what you were doing.
Mhm.
The exams were in all subjects, not just math. There was science, there was religion, and that sort of thing.
Yeah.
Um, and you had to understand what you were doing. Um, so the way we test and the way we hold people responsible for good test scores is a detriment to actual learning. Because if you're concentrating on, oh yes, always pick option C because that's what it usually is, uh, then you haven't learned anything. Test taking skills will not get you uh, anywhere in the real world.
Yeah.
So anyway, it's getting good teachers in and letting them do what they need to do without forcing them to do other things.
In your career, you've seen the development of the personal computer and all kinds of technological aspects. What difference should artificial intelligence, AI, and technology make in the teaching and learning process?
I'm just scratching the surface of AI. I know that when the calculators came along, people thought, oh, they won't have to memorize their facts anymore. They'll just use the calculator. But you can use the calculator, and particularly the graphing calculator, to convey concepts also. And what we found in calculus was you used to find derivatives, which is the rate of change of a function, to find to draw the graph. You say if the derivative is positive, the graph is going up. So you would make your graph go up. If the derivative is zero, it's reached a high point or a low point. So we used derivatives to draw graphs. Now that we have graphing calculators, we can use calculators and graphs to understand derivatives rather than the other way around.
Okay.
You got to adapt your teaching methods to take advantage of the way things are,
Sure.
not to say, oh, you can't do that. I have heard somebody said back in the ancient days when they invented writing, everybody said, oh, the kids' brains will rot. Now they won't have to memorize everything. Whether that's true or not, I don't know, because I was much younger then, like 1,000 years younger. Anyway, um, we need to adapt. And the AI, I've seen some interesting work that they're doing with AI in Algebra 1, and actually using my book as input for some of that.
Interesting.
Uh,
Yeah.
and it's looking pretty good.
Yeah.
I have not used it myself. It's occurred since the 14 years ago when I retired. Um, but I have seen some results of it that are promising.
Yeah. When I got involved in classical education, which was around 1992,
Mhm.
we were faced with the question, which was the big question of the day, how do you use calculators?
Mhm.
And we adopted a mindset that calculators should be tools and not crutches. And that
Exactly.
seemed to resonate with many people in classical education and more broadly. It was the idea that we still need to learn the math tables, but that doesn't mean that we don't get to use a calculator at some point.
Mhm.
Master that, and it makes sense. But the idea, you mentioned the graphing calculator as an example. If I understand the algebraic equation by having solved it a few times, it becomes a bit of a waste of time to not use technology to see what that formula will produce in the form of a graph.
That is correct.
And
Yes.
so that was a good example of it being used as a tool and not a crutch. And that seemed to resonate with a lot of people as I've done speaking over the years related to that. Does that resonate with you? Does that make sense? How would you further embellish that?
Well, you've got to realize that students uh, can get in a rut. I had when the computer algebra systems calculator came that would do calculus. I had a student that had one, and he never learned to integrate x squared uh, in his head. He always used his calculator, and that was a shame.
Yeah,
And so I developed the saying, you can that you have your mind has so much creative energy at any one time. You cannot afford to use all your creative energy on tasks that should be routine. So you've got to learn some things. You've got to learn to integrate x squared, for example,
yeah,
and know what that means without the technology. The simple things you should be able to do in your head, like arithmetic.
yeah,
Um,
yeah.
so there,
We had an experience over the weekend in the grocery store where my wife was faced with buying a vegetable. I'm trying to think what it was. I think it might have been a lettuce, and they
Mhm.
had smaller packets and larger ones, and they were in two different locations. And it was kind of fun to watch her because I'm the math guy between the two of us, and she's not. But she knew unit cost and those sort of things, and she had to quickly say, "This one's cheaper. I'm buying this one."
Mhm. Okay.
We think we don't use math, and we use it every day.
Yeah. Mhm. Anyway, that's something that you can't afford to do. You can't afford to use up all your creative energy doing two plus three.
Yeah. Yeah. Well, Paul, it has been so good to have gotten to know you a bit over the last couple of years, having had many of our students appreciate your writing and your teaching through your books. And now having had a chance to really talk to you a bit more here today, it's been wonderful. Thank you.
Well, I appreciate what you're doing in keeping those books alive. Um,
Well, yeah, that's very kind of you. It's a blessing to both of us then.
Thank you so much.
Thank you. And folks, thank you for joining us on this episode of Veritas Vox. We hope to see you next time.